In this video I want to build my home lab server from scratch with Linux. And if you also want to build your home lab server, there are hundreds or even maybe thousands of different ways how you can do this. And I really thought a lot about how I should approach this. So which type of hardware should I buy? Should I just buy a new expensive server rack, or should I just use an old computer? And then I thought, well, this mainly is just a fun and learning project for me. So I want to learn more about the underlying technology and how to use it. But it also needs to be built upon common IT industry standards that are rock solid. And this is why I decided to install the Ubuntu Linux operating system on a Dell Poweredge T410, which is kind of an already outdated hardware model, but I think you can learn so much more if you can get your hands on real server hardware and install the Linux operating system and build all these technologies and services from scratch. So we will install a file system with ZFS, we will install a hypervisor with KVM, and if you want to build your own home lab, I think this can be very helpful, because I also want to talk a bit about the hardware and what you should consider if you want to build your home lab upon those real server hardware components. So if that sounds all interesting to you guys, keep watching. Hi everybody, my name is Christian and I always make great tutorials and content for IT professionals. I also stream every Wednesday, Thursday and sometimes Monday on Twitch, so if you have any questions or problems, you can just come to my live stream and we can have a discussion about that, so check that out. In this video we want to build my home lab server from scratch with Linux, and I also want to talk a bit about the common problems or the things you should consider if you also want to build your own home lab. Okay, so let's step right into this and talk a bit about the hardware and why I have chosen to buy the Dell Poweredge T410. So note, this is not a recommendation that you should buy exactly the same server model, so you can of course just use any other type of server or computer you want to use. So if you have an old computer and you want to make this your home lab server, you are definitely fine to do that, yeah? But you should consider that most of these consumer components, especially the hard drives and the power supplies, are not really made for 24/7. So if you plan to run that all the time, you should consider buying real server hardware. And this is exactly also one of the reasons why I bought that. And I think it also can be very interesting to get your hands on real server hardware you usually would only see in a corporate or company environment, because there are a lot of things that are special about this. Those server models actually don't look like a normal computer, and they come with a lot of components, especially redundancy components like 2 processors, 2 network card interface, 2 power supplies and multiple hard drives you can easily connect to a backplane with a RAID controller. So if you're not familiar with real server hardware, I think this can be a very interesting and a very good project. One thing that I can definitely recommend to you is look for server models that are from 5 up to 7 or even 10 years old, because you can get really good offerings. For example, the Dell Poweredge T410 that I bought, that comes with 2 processors. Each of these processors have 4 cores and 8 threads. So ultimately I got 8 cores and 16 threads with 16 gigabytes of memory, and that for $70. So that is very affordable and is very cheap. Just have a look, and you can also search for different vendors like HP and look for their ProLine series or the Dell Poweredge series. One thing you should consider if you buy a real server hardware is that those servers usually are much noisier than a normal consumer PC. So if you plan to put that in the same room where you're working, that can be really annoying, so you should definitely place the server in a separate room. The next thing you should consider is the RAID controller, and this is a very important thing, especially if you want to build your server and your file system with ZFS. ZFS is also a very performant and solid file system, and this is the reason why it is also commonly used in the open source solution FreeNAS that is based on BSD. And ZFS comes with a lot of advanced features like redundancy options, like compression or caching, and we will not talk about all the details in this video because this would be just too much for a single video, but I will also cover this topic more in upcoming videos. So if you want to know that, and if you want to learn more about this technology, don't forget to subscribe to this channel. But what is now the thing you should consider in terms of RAID controllers? Well, one thing that is special about ZFS is that it actually wants to have direct access to the hard drives. So it's definitely recommended to directly connect those hard drives to the mainboard so that your operating system and especially ZFS file system can have direct access to through your hard drives. With a RAID controller, then we have a problem, because the RAID controller wants usually to manage the RAID itself. So that creates a different layer and will manage a RAID system and then forward this virtual drive to the operating system. And this is something ZFS doesn't like. So there are some problems that can occur in this setup, and this is why you should get a RAID controller that offers the pass-through method. So the RAID controller actually bypasses this RAID hardware level, but only a few RAID controllers have this option. Then you have a second solution. You should look if your RAID controller has a custom firmware that will put this RAID controller in the so-called IT mode. And this IT mode is a special firmware. You can flash your RAID controller with this firmware, and this will also bypass the hardware RAID layer. Then you also need to plan which type of storage devices you want to use. So I needed to also buy an SSD hard drive where I want to put the operating system just on this single SSD. And I also bought 4 SATA drives with 500 gigabytes. I know this is not really much, but this is just an experimental project, so of course you can just buy any SATA drives with 4 terabyte or whatever. Okay, so I talked a lot about hardware. Let's step right into the installation process, but I think this is a very important topic, especially if you're not familiar with real server models, and if you're just a beginner and you want to get your hands on real server model. Don't skip that part and really make a proper research on your server model, what type of RAID controller is built in, if it supports the IT mode, if you want to use ZFS and so forth. Okay guys, so then I just installed the Ubuntu 20.04 LTS operating system on the internal SSD hard drives. I didn't touch the 4 500 gigabyte SATA drives, so I just installed Ubuntu. And the first thing I always want to do is make an update all the server packages, and then we can start with installing the ZFS system, because usually a Linux operating system doesn't come with that by default, so we will need to install the kernel modules and the utilities for that, and let's start with this. Okay, so the packages are now updated, and let's install the ZFS utilities with sudo apt install ZFS utils-linux. Okay, so this is now installed. I can now also check with lsmod and grep for ZFS if kernel modules are loaded. And you should see something like this here. I also want to show you what different hard drives are connected, so let's execute the command lsblk. That will show all the hard drives on our system. By the way, you don't need to remember all the commands. I put you a link to my written blog article there. You can just copy and paste those commands. And I also will create a cheat sheet on my blog article. There you can get a list of all different commands, how to manage ZFS file systems. So check it out. Okay, so you can see I have added 5 hard drives here. So we will start with the first one. This is the SDA, and you can see this is a 500 gigabyte hard drives here. Then we have the SDB, SDC and SDD, which also are the 4 5 gigabyte hard drives that are connected to the backplane of this server model. And I also have the internal SSD drive. This is a 250 gigabyte SSD drive that is mounted as SDE, and you can see this is also mounted with a root directory, so the Linux operating system is installed here, and those 4 drives are empty. So I've done some testing with ZFS, therefore we have the second partition here, but don't worry about this if you don't see it. That will be created by ZFS once you add them to a storage pool. Okay, so before we can create a storage pool, I also need to talk a bit some theoretical stuff about ZFS and RAIDs and all the different redundancy options, because there are 3 main different options, and they are really different in terms of redundancy, performance and so forth. So let me also talk a bit about this. So the first mode you have is the stripe mode, and this will just stripe all hard drives together and add the disk size together. So you have no redundancy options there, so if one drive fails you definitely will lose data. The advantage of this is that you will increase the performance, especially when reading and writing. And this probably is not obvious, but if you want to write data to a disk and you have a stripe area of those disks, you can actually split the write and the read load upon all the hard drives you're using, and this is why it is much more performant than just use a big single hard drive in this case. So stripe can be beneficial if you want to get additional performance, but note, if one drive fails, you're losing data. So therefore we have the second mode, and this is a mirror mode. So this is just a mirror between 2 hard drives, and this is actually a redundancy option. So you're writing the data to 2 disks, and if one disk fails you still have all your data, and you can replace this while the server is running if you have a hot swap option. So note, this is also increasing the performance, but it's only increasing the read performance, because you can read from both drives at the same time But if you want to write data, you still need to write the complete data to each hard drive. And you're also losing 50% of your disk size, because the second drive is only a mirror, so it actually has the exact same data like the first drive. And then we have the RAID Z. Well, there are two other options here as well, but I don't cover them, so I mainly will focus just on the RAID Z1, which is equivalent to the hardware RAID 5. So that requires a minimum of 3 hard drives, and that will store the data on 2 hard drives, and the third drive is a parity section. So that is actually important when you want to recover the data, so that also adds some redundancy. So you can use 2 drives to store your data, and the third drive is to recover if one of these drives fails. You can also add more than 1 drive to this RAID Z. So for example, you can also add 4 or even 5 or 6 drives, and you only have 1 drive as parity. So this also increases the performance, but note it won't really so much increase the write performance, because you also need to write that parity section. But for most people, RAID Z is the best solution, because it is usually the best compromise between disk space, redundancy and performance. To create a storage pool with ZFS, we need to execute the command sudo zpool, which manages all the storage pools, and let's create a new one that is called store, for example. And then we will need to add the level of redundancy, or the level of storage pool we want to add. So in this case, I want to add a RAID Z pool. And now we will need to specify all the drives that we want to include in this storage pool. So I want to include the dev SDA, the dev SDB, the dev SDC, and I also want to add the dev SDD. Remember, for RAID Z1 storage pool you need at least 3 hard drives, but you can add as many if you want. To check if everything was successful, just execute zpool status. And then you can see we have one RAID Z1 storage pool, and we have those drives as a member of this storage pool. You can see they are online, there are no errors reported. So if you see a state online, everything is working fine. But let me also pull out one of these hard drives of the server, and let's see what is happening then. And you can see this is called degraded now. So degraded means there's 1 or more devices that are taken offline. So this can be because the device is just missing, like in my case. So this is a SDC, which is offline. And you can now just replace this drive and replace it with a new one. So if we execute an lsblk, you can also see the drive is now missing here. So this is just the reason why this RAID storage pool is now degraded. So let me pull in the hard drive again. And now it's online again. So ZFS automatically mounts this in the root directory. So if we go to the root directory and execute an ls command, you can see there is a new folder that is called store. And if we go to that store and write any data here, this is actually stored in the RAID Z storage pool. So you can also see that storage pool has 1.3 terabyte of free disk space. Why it is not 2 terabyte? This is basically because one drive is used for the parity section. So we are losing the disk space of exactly 1 drive when we're using the RAID Z1. Let's also test the performance. So to do that, I will just write and read some data. So I will use the command dd to just write block size data, and we will use an empty file and put this file to the store test1.image file. The size is 1 gigabyte. Let's do that once and just write some data to that storage pool, and let's see how fast this is. You can see it's writing with 178 megabytes per second, so this is not bad. But as I said, the write performance is a bit slower than the read performance. So let's also compare this, how it works when we read the data. So for example, we will use the file store test1.image as an input and output this on the dev0. So bssak, and let's just execute this. Oh, I just forgot the equal here. And you can see it reads with 800 megabytes per second, so which is much faster. But you could also combine a stripe in the mirror, and this is also very interesting because we can stripe 2 mirrors of 2 disks. So you actually need 4 disks for that, and we will create 2 storage pools that is a mirror of 2 drives. So we will lose one of these drives for redundancy option, and then we will stripe them together. So let's also have a look at this and create this combined storage pool of the mirrored stripe and then we will compare the read and write performance with the RAID Z pool. So first we can create this Z pool with the create command and call this store again. So now we need to simply create a mirror between two drives. So we will create a mirror, dev SDA and dev SDB. And we will create a second mirror. So this will automatically stripe those two mirrors. And the second mirror is creating of the SDC and dev SDD hard drive. And if we execute a zpool status, you can see this has now created a storage pool. This is always a striped pool of those different sub-pools here. So we have a mirror 0 and we have a mirror 1, and this is containing those drives. Okay guys, so if you assume now that we can lose two drives now, actually not really correct. So let me do a quick example. So if SD1 for example fails and SDC fails at the same time, well, this is fine because we have still the redundancy drives here. But if SDA fails and SDB fails, we are losing data. So you need to consider that. So you still are not really able to lose two drives. Well, it depends. That is, of course, a bit unpredictable. So no, this is very, very important here. So you're not doing this to add more redundancy to your storage pool. You're doing this to increase the performance. So let me show you this. Let's also read and write data from the interface dev 0 to... can't write today. So I'm using the exact same commands like with the RAID Z1 storage pool. Let's hit enter. And you can see it's writing data much, much faster. So remember, with the RAID Z pool we had something with 170 megabytes per second, and now we have almost 700 megabytes per second. So this is much, much faster. But note, if we are reading data, test1.image and output this to dev 0 with bs equal 8K. This is almost the same speed. So we have something like 800 megabytes per second. I think this was very similar to the read performance of the RAID Z pool as well. So what does that tell us now? Well, this tells us two things that you should consider here. So first is you can combine those different pools here. So for example, if you have 6 drive, you could also combine a mirror of 2 RAID Z1 pools if you want to do that. You can also add other mirrored or RAID Z pools later and stripe them together. You are very, very flexible here, and the more drives you add to this stripe pool here, the more performance you will get out of this. Also consider you are losing space with every redundancy option you add. So if we execute a df-h, you can see this pool only has 900 gigabytes of data, which is actually not very much. So I usually should have 2 terabytes of data, and I've lost 50% of my disk storage just because I added this mirrored stripe pool here. So that is something you should consider, and this can get really, really expensive. So which solution you choose is up to you. Note, you can always change that later. So you cannot really add another drive to RAID Z or to a mirrored pool, but if you have a RAID Z pool with 3 drives, for example, you can add later another RAID Z pool and stripe that together, for example. So there are a lot of different combinations you can choose. Of course, ZFS has a lot more different advanced options like compression, caching, and also snapshots, which are very useful, and this is mainly the reason why most people are using ZFS, because of the snapshots. But I don't want to cover all of these different options in this video. But if this was helpful to you, don't forget to hit the like button, and please tell me in the comments if you want to see more tutorials and videos about ZFS, and especially if you want to see more ZFS videos about compression or caching or snapshots, whatever. And then I can of course also make other videos about ZFS. Okay, so we have talked enough about storage pools, enough about hard drives and so forth, and let's actually start with the installation of a hypervisor, because this is the main reason why I want to build this home lab, because I want to install more virtual machines on that, and I will store all the virtual hard drives on that ZFS storage pool. Okay guys, so let's also install the KVM hypervisor on the Linux operating system. To do that, we will install some different components, because it's not just one component, it's consistent of many different things here. So first we will need to install the QEMU, which is the hardware emulator. Then we will need to install the QEMU KVM, that is basically the hypervisor. Then we will need to install the libvirt daemon, which is the daemon that runs all the virtual machines. The virt-inst, that will install some utilities, how to manage those virtual machines and how to create them. And also the bridge utils that will enable us to create those bridge interfaces for networking. So let's hit enter, and that will take some time until all those components are installed. So now we should always check with the sudo kvm OK if the hardware acceleration can be used. And if you see something like this here, KVM acceleration can be used, that is fine. If you don't see that, you probably have a very old processor, or you don't have enabled the virtual machine acceleration in your BIOS. Now we can check with sudo systemctl if the libvirt daemon is running. libvirt-d, so, and you can see this is now currently active and running. If this is not the case, you probably can just enable this and then just enable --now. This will automatically start the libvirt daemon. And then you could check with the status, okay, everything is working fine, and we can now start creating virtual machines and so forth. If we execute an IP ADDR, you should also see something like this here, the virt-bridge 0. So this is also created by default, and this is a simple bridge interface, and this is a NAT device that will NAT this internal network here to your physical network. You could also add your current user to the group KVM so that you don't need to execute sudo anymore when you enter the vir-sh or something like this here, and this can be also very useful. So now we can simply just use the command line tools vir-sh and virt-install to manage networking, storage, install virtual machines and so forth. And I don't want to cover everything here in this short tutorial because this is just too much. You probably just should have a look at some documentation of vir-sh or virt-install if you want to create virtual machines in the command line. But you could also use a graphical virtual machine manager. This is called virt-manager, and that can just simply manage any virtual machines. So if you don't have installed a graphical user interface on your server, just like me, you probably need to run this virt-manager on a second computer and then connect through SSH to your home lab server, and then you can also manage those virtual machines on your remote computer. If you're running Linux, this is probably pretty easy. You just install the virt-manager on your Linux operating system, set up a private and public SSH keys to authenticate through SSH to your home lab server, and then you can manage with the graphical tool virt-manager all your virtual machines on your home lab server. If you're running Windows, that is probably not so easy because virt-manager is not natively running on Windows. This is just a Linux program, but I found a very easy solution to just make this available on the Windows subsystem for Linux, and this is also pretty interesting. So what you need to do is you need to install a VcXsrv, that is an X11 server that is running on your Windows operating system, and then execute a special command to attach those graphical programs within your Windows subsystem for Linux to connect to the X11 server on your Windows operating system. So with this you can run graphical Linux programs from within your Windows subsystem for Linux on your Windows host operating system. One thing you need to do is you need to execute this command here, and remember you can find this on my written blog article, just copy and paste it. So this will just export the display variable and will search in the resolve.conf file for the IP address of your Windows host operating system and put this into this variable here. So you can also check this with echo display. So if you executed this command, you should see this is the IP address of your Windows operating system with a column 0, so that means that the display is then attached to the X11 server on your Windows operating system. Now you can simply just execute this command here, apt install virt-manager, and this will install the virt-manager on your Windows subsystem for Linux. Now if you have installed that, then you need to install the VcXsrv on your Windows host operating system. Start it with the command x launch, and then just configure your system. Then disable the access control, click on next, and this will now start the X11 server on your Windows operating system. Now if you execute virt-manager, this will automatically start the program and you can simply just use that within your Windows operating system. So this is a virtual machine manager where we can just create new virtual machines, manage existing ones and so forth. You should see a message like this here: the virt-daemon service is not installed on your operating system, of course, because you need to first connect to the remote computer. So as I said, you first need to set up private and public keys to that before doing this, and I always would recommend this if you're running this in your home lab. Just always use SSH private and public keys to authenticate to your remote server. But what you simply need to do is just cut your public key that is located in your .ssh. So you, of course you need to create that first. If you don't have this file, check out my video how to create private and public keys and how to use that to authenticate to Linux servers with SSH and copy files with SCP. So I've put you the link to the video in the description below. And then you can simply just copy the public key, go to your remote server, and then just echo this and put this into the .ssh authorized key files. So now we should be able to authenticate via private and public keys to this server here, and this is important for the virt-manager program. So when I execute this here and the program starts, I want to add a new connection to my remote server. Just click on connect to remote host over SSH. Just choose your username, set up the host name. So if this doesn't work, you probably have done something wrong with the private and public key authentication. It usually prompts you to add a program like SSH KeyPass or something like this, but you can simply avoid this when you set up this private and public key properly. And now we can just simply use that to create new virtual machines. So when we create a new virtual machine, it opens a new window, how we need to install that. But first we need to download an ISO file, because I haven't done that before. And just create a new folder with root user's permission that is called ISOs. And I also want to change the owner of this to my Linux users, because I don't want to execute sudo all the time. So if you don't know how this is working, you can also check out my Linux command line beginner guide. There I will teach you everything about Linux command line basics and so forth. Put you a link in the description below. Now I simply go to my Windows subsystem for Linux, because I can just simply copy with SCP, and I just go to the mount departition where I have already downloaded 2 Ubuntu ISOs. I will of course use this newer image here and just upload this to my new server and store this in this directory. Okay, so let's go back to my server and let's execute an ls command, and we should see the ISO file here. We can also copy this and go back to the virt-manager on my Windows subsystem for Linux. Just click on local install media. So this is locally on my remote server, yeah. And now we will just simply go to the store ISOs and paste this ISO image here. Let's go forward. This is trying to detect the Linux distribution here. Let's give them a bit more memory and add more CPU cores. As I said, I have 16 threads because I have 2 processors with each 8 threads, and you can see there I have a lot of computing power here on my home lab server. And just go forward, and I will create a new disk. So probably I won't do this now, because I want the virtual hard drive to be stored on my ZFS file system. So let's just disable this. We will do that later. And it somehow didn't recognize that properly. So let's also add the name Ubuntu test server, for example. You should always check this here, customize configuration before install, because we want to change some settings and add a virtual hard disk to this machine here. So add new virtual hardware and go to storage. Now we can create a new disk here, and we can now select or manage custom storage here. So this is very important, because I haven't set up storage pools before. So you can see it automatically created an ISOs folder at this location here, but the default location is always the /var lib virt-images and so forth. Of course, I could just change a or add a symlink here to point this to my ZFS file system, but I also can create a new storage pool here that is called store, or let's call that a vm-store. And the target path is now store vm store. Let's finish. And just add a new volume here. Let's create Ubuntu test server disk.uco2. Let's give that 40 gigabytes. Let's finish. It's creating the virtual hard disk, and this can be connected to the virtual machine, and we will install the virtual machine on this disk here. Choose the volume. And now we can just simply change this from IDE to SATA. Finish. And now we can begin the installation here. Okay, so we have now installed and set up my home lab server from scratch with Linux, and I can now basically start use that, install virtual machines and play around with it. And if you haven't already done that, please don't forget to hit the like button if this was helpful to you, and leave me a comment what types of topics you want me to cover on this as well. And if you want to see more topics about home lab stuff and basically for any IT professional, then don't forget to subscribe to this channel. A quick reminder, I stream every Wednesday, Thursday and sometimes Monday on Twitch, so if you have any questions, just come to my live stream and we can have a discussion about this, or just hang around. And before I go, I want to thank all my supporters on Patreon, especially Mason, who is the producer of this show, so without you, the community, this whole project wouldn't be possible at all. So thanks everybody for watching, enjoy the rest of your day, take care of yourself, and I see you soon.